Hello guys, welcome back to this video. So in this video, we'll be starting pre-layout and post-layout timing, static timing analysis. So coming to our topic, I'll give you a general introduction between the flow graph or the pre-layout and post-layout time analysis. And then individually, we'll see one by one that analysis will be done by other teammates. So let us compare the first pre-layout timing analysis. We'll see there are a number of steps here. And also in the post-layout timing analysis, the same steps will be there. That's why I have shown like this, why not repeated, except one extra step will be there that will be replaced. So let's see what is the flowchart timing analysis. So now in detail, these all steps will be given further by my teammates. Thank you.
The first step in STA flow is to read libraries. Let's say I am a library. I give information regarding gate cell delay, slew rate, PVP additions, noise margin, setup hold time, pulse width value, etc.
The second step is to read netlist. I am netlist. I have all the information of cell types and the select seed coordination. Cell types are being used in current library.
The third step in STA flow is wire node model. In Prelayout stage, actual resistance and capacitance is not available to calculate net delays. Net delays are being calculated based on 5 nodes. The information comes from libraries in lookup tables.
The fourth step in the STA flow is to read the constraints. I am constraints. The constraints are very much important for performing static timing analysis for getting correct results. The constraints given should be accurate in order to identify all the timing issues. The constraints includes clock definitions, AOCV, OCV parameters, input and output delays, max-min transition times, max-min load values.
I am the fifth step. I perform timing checks, where timing paths are verified as per constraints information. The timing checks I perform such as setup check, hold check, recovery check, human chip, transition or DRC check, minimum pulse width check.
So now I'll be discussing more on timing checks. So now let's quickly see what involves in the timing checks. Firstly, timing checks is a very crucial step in the STA flow analysis. So let's see what all the factors consist under timing check. There are some factors which I listed down. One is block scales, setup and hold time, pulse width violation, and maximum frequency violations. So first, coming to the block scale, it means that we have to ensure that block is evenly distributed to all the modules which are present, to all the blocks, registers, or flip-flops which are present in the design. Second thing comes setup and hold time, which means that the data should be actually stable. The setup time basically means the data should be actually there even before the block is high, and it should be stable even after the block has left. Third timing check comes as pulse width violations. That means the pulse width, this one pulse width, we have to make sure that the pulse width is also correctly defined, because what happens if your duty cycle is improperly defined, again it will lead to some errors and that will be caught in the timing check. So this should also be ensured that all the pulse widths should be correctly mapped. Then comes the frequency violations. That means your design should be operated at certain frequency. Apart from that, if suppose we have some threshold frequency for a particular design, it should run under 1250 megahertz. And let's say for some reasons your design is working for some 50 megahertz or some 500 megahertz, which is very less than your threshold 1250 megahertz. So again, what will happen? Your design will be slower because your clock is running at a very low frequency than this. Suppose it's only running at 500 megahertz. So you can see it's almost half of it. So your time will increase. So hence again we will have these timing checks error. That means we will our runtimes will increase.
The next step is analyzing the timing report by capturing all the paths based on the constraints that are provided. Usually, designers won't prefer to take the report of the beyond failure path. So the constraints are provided in such a way that only failure path report have been generated.
The generated report has no timing violations for. I am forwarding it to the physical design team.
If there are any timing failures found in step 6, then I need to analyze those paths and provide feedback to the synthesis and physical design.
Generated report has no timing violations for. I am forwarding it to the fabrication team.